We've looked at some specific examples of having something that appeared to be a sinusoidal wave and how we took that graph and found an equation that would come close to matching it. In this video, we'd like to just talk about that process in general. The first step is to decide which you prefer, to think of this as a sine curve or to think of it as a cosine curve. Both of those curves have exactly the same shape, it's just that one is shifted from the other. So once that decision is made, then find the y value of this middle line. That's going to tell us how much up or down this has been shifted. In this picture, obviously the sine or cosine curve has been slid down, so d is going to be a negative whatever this distance is. So you find where this line crosses the y-axis, and that tells you what the d is. Once we've identified the middle line, then it's halfway the distance from that middle line to a high point, that distance from the middle line to the low point is the same. And that distance from the middle line to the high or the low point, that distance is what the amplitude is going to be. Now in this first example, I'm thinking of this as being a sine function. So I'm thinking of it as starting right here. And we need to find out what that particular x value is. Where does our sine, the first cycle of our sine function begin, and where does the first cycle of that sine function end? So I'm thinking of using this particular equation. Once we've identified where a sine cycle begins and where it ends, xi and xf for x initial and x final, then we put those values into this argument. The sine needs to think that it's seen 0 when x is xi. It needs to think that it's seen 2 pi when x is xf. So now it will be a matter of solving this system of equations to find out what b and c are. Once that system of equations is solved, we have now identified what a, b, c, and d are, and we can write an equation that will come very close to drawing this particular curve. If you chose to write your sinusoidal curve as a cosine, then finding the a and the d would be done identically the same way. You'd find this middle line of the curve. You'd identify how far it has been shifted from the x-axis. That's going to tell you what d is. Once that's been identified, then you can identify what the amplitude is, and that's going to tell you what the a is. But then, because we're working on a cosine, you will find some starting point of the cosine and some ending point of the cosine, x initial and x final. You'll plug those x values in. The cosine needs to think that it's seen 0 at the starting point. It needs to think that it's seen 2 pi at the ending point, so we will need to solve this system of equations to find out what b and c are, and then we know all the parts to write this particular equation.